Hello everyone, this is Puya. Today I'm going to talk about exception handling in C++. Before we talk about exception handling, let's see what kind of errors can we get in a C++ program or any other programming language. So we can categorize the errors that a program can have into three main categories. The first kind, which is the most frequent one, is the syntax error. Syntax errors occur because of programmers' fault in writing the program and not following the syntax of the programming language. Um, so this might be due to typos, might be due to lack of knowledge of the syntax. So for example, if you don't know about the case sensitivity of the language, or if you have a typo, or if you forget to put semicolon when it's needed, or when you forget to close a bracket, etc. So these kind of errors are basically which happens because of not following the syntax of the programming language are called syntax errors. In the case that we have syntax error, the compiler cannot compile the program and it would terminate the it would never execute the program. It would just like give us some error messages, and these error messages should help the programmer to rectify the problem. Usually like it would provide the exact location of the error and what caused the error, so then the programmer can resolve the issue. The second kind of errors are logical errors. These logical errors are very hard to detect and very hard to debug, mainly because the compiler doesn't give us any help. In these cases, the program compiles and is executed successfully. Successful in the sense that like it doesn't generate any errors, any syntax errors. But the results are not the results that the programmer expects. So let's say that you're searching through an array, or you want to sort an array, or you want to do a certain operation with some variables, and once you run the program, you see that the results are not as expected. This is again due to programmers' errors, programmers' fault, like not understanding the problem, not doing the algorithm right, not designing the algorithm right. And because the compiler doesn't provide any hint, doesn't provide any errors, these are like hard to detect. One main solution to fix these kind of errors is using the debugging services that the IDE, the integrated development environment of that like program that we have, provides to run the code one line at a time and keep track of the variable values, the like function calls, the objects in the program, and just basically follow where the program goes and like at which point the results turn out to be not expected, and hopefully the programmer can fix the issue. Excuse me. So these are logical errors. The other category of errors are runtime errors, which is related to today's topic. So runtime errors happens when the programmer write a program. The program works fine in most cases. So, but when the programmer delivers the program to the user um, in certain scenarios might provide the wrong input data. So, or the resources that should be available um, are not available. So like an analogy would be, for example, if you provide like food to a kid and the kid starts eating with his or her foot instead of with the hands. So not using the proper tools or not providing the right input or not having the resources would lead to these kind of runtime errors. So this is, we can say it's user's fault, like for not providing the right input or not making sure that all the resources are available, but um, actually, like, this is programmers' fault for not foreseeing these kind of scenarios. um, so at the runtime error, when the user provides the wrong data or for some reason the program cannot run in that specific scenario, the compiler terminates the program abruptly, and basically this termination happens because of the wrong input data or lack of resources. So the programmer actually should foresee these kind of errors and these kind of issues, and should provide a solution for it so that the program doesn't terminate. Instead of terminating, we want the program to give some guidance to the user with some warning messages or with some error messages to let the user know what kind of data is expected or like what kind of resources should be available. So an example of a runtime error is when, for example, the program expects the user to enter a positive number and the user enters a negative number. Or let's say that you want to read a file, but that file doesn't exist. Or you want to write on a file and the file is write protected. So these kind of issues cause the program to terminate, and we should write the program, we as programmers should write the program in a way that this termination doesn't happen. Um, so just to give you an analogy, let's say like once you get into your car, if you forget to fasten your seat belt, would it be ideal if if the car just all of a sudden stops? We don't want that, right? We don't want the car to stop running just because the seat belts are not fastened, but we want the car to give us some signals, some indicators that what the problem is and how to fix that problem. So this is today's topic on how to fix these kind of runtime errors. These runtime errors are basically exceptional cases, right? So this, like, a program might work correctly 99% of the time, or like most of the time, or like 50% of the time once you provide the right input. It only causes the error in exceptional cases. That's why, like, we call these kind of errors are exceptions. Well, in C++, exception is like defined another way, but like this is like what the exception is, like a runtime error that happens due to lack of resources or the wrong input. And how to fix these kind of errors or how to predict these kind of errors is called exception handling. So exception handling is the process that the user implements in the program to make sure that if these errors, these wrong inputs or lack of resources happen, um, the compiler doesn't terminate the program, doesn't doesn't basically finish the whole program at that point. We want the program to continue, but at the same time we want to give some signal, some indicator to the user so that he or she knows what went wrong. Okay, so with this introduction, let's see what an exception is. An exception is an unusual and often unpredictable event that's detected by software or hardware that requires special processing at runtime. So in C++, exception, it's regarded as a variable or class object that is corresponding to an exceptional event. So this might be a little bit vague at this point, but we're going to see what that means. An objective of exception handling is to inform the user about the problem and guide him or her how to fix it. Without handling, program crashes and falls into an unknown state. It means that like basically like these line to line compilation and execution stops, and we don't know where the control goes over. So we don't want the program to crash. We don't want to get into an unknown state. An exception handler is part of the program, part of the code that's designed to execute a particular like a particular process when these exceptions happen, and to resolve the exception, like basically resolve the exception. By resolving the exception means like to let the program to continue running and lead to a known state. So it means that skipping that exception part and continue the program, or like exiting the program in the usual manner and providing the hint to the user. So like it's often easier to write a program assuming everything is going to go well, but usually that's not the case. The user, like we don't have any control over like what kind of values he or she would provide for inputs, or like how the user would use the program. So once like the program works correctly, everything is going to go well, but like there might be cases that something goes wrong. So for those cases, we need to have exception handling. This is programmers' responsibility to write a stable program so that it doesn't crash. We'll see that a common use of exception handling is when it comes to functions. So when it comes to functions, especially the functions that are supposed to return something, um, the exception handling is going to be very important. If these functions are used in different programs, each program might require a different action. So like for example, if you have a division by 0, you might have to do something. If you have something else, if you have like for example like if you go out of memory of, or if you have overflow or underflow, you might have to have a different strategy basically. Uh, in C++, there are 3 keywords that we have to know for exception handling. Those keywords are try, catch, and throw. So basically, like anytime an exception happens, the exception handler part of the program should throw an exception. This is the term that we use, throwing an exception, right? And the part of the code, another part of the exception handler would catch this exception and handle it. It basically means that it does a certain operation at that point to handle the exception, to handle these special circumstances. So an example from the textbook for this course or for the previous course that you guys took is given here, that this is basically a division example. We just want to like get 2 inputs from the user. One of the variables is called donuts, the other one is called milk, and we want to divide donuts by milk. Okay, if you guys forgot about the static cast, you have to review this concept. So like we just want to basically get double value here, so that's why we made this one, we casted this one as a double. So we just have a division, right? If you're dividing 1 by 2, everything goes fine. If you divide 5 by 2, everything goes fine. 3 by 3, everything goes fine. But let's say that the user enters 0, okay? The user enters 0 or enters -1, right? If you enter -1, this is going to be a logical error, but happens at runtime because no amount of milk can be negative, right? So in these cases, the programmer doesn't have any control over what the user is going to enter. If the user enters a value 0 for milk, we would have a division by 0. In this case, the program would terminate. If this is the program that we have, the program would crash at this point. And the rest of the program, let's say like this happens in the middle of the program or at the beginning of the program, the rest of the program would be not even run. So like, and the control goes over into an unknown state. So one way of fixing this problem is the code that you see on the left part of the screen. So we can use an if-else block and just basically solve the problem like that. In some cases, fixing an exception can be done with an if else. Like for example, in this case, it's very easy to write an if else and just basically say that if milk is less than equal to 0, do something else, do the division, right? So this is like how we give a hint to the user if the user enters the wrong input. For this problem, if we want to use exception handling, there are 3 keywords, as I mentioned, we have to know. Try, catch, and throw. So in the try block, we write the part of the code that does the operation that we want to do, right? So in this case, division, right? So you can see that here in the try block, we did everything that we wanted to do. But before getting to the point that a wrong value or the user's fault might crash the program, we predict the case. We know that if the user enters a negative number, this is not good. So in that case, we throw something. Okay, so here like we are throwing donuts. Like this is a variable that we are throwing. I'm gonna explain this a little bit later. So like we have to throw something. Here like we are throwing donuts, which if you can see is of kind int. You can see it here. So excuse me. So we have to throw something. As soon as you throw something, you are gonna be kicked out of the try block. Or like in the most correct way of saying it, it's going to be that the control goes over to the catch block. So you're going to be moving from the from the try block right to the catch block, and the variable or object that you threw, it's going to be caught here. So basically E is going to have the same value as donuts. Okay, and in the case that you were thrown out of the try block, then the catch block would execute. Once the catch block finishes, it would continue, the program continues. So the program doesn't crash. The program doesn't crash anymore. If the user enters the right data, excuse me, positive values, non-zero values for milk, then the try block would continue. So basically this if is going to be skipped. We never throw something, so this finishes, and the catch block is skipped, right? So you only go to the catch block if you're thrown out of the try block, if you throw something out of the try block. So that's why, like in the beginning, in the second slide, it said that in C++, an exception is a variable or an object that we throw. So this corresponds to the exception that happened here, which is like milk being negative or equal to 0. We throw a variable. Because this variable is of type int, we have to also write the parameter for the catch block as an integer. Okay, so here, like, assume that this is a ball that you want to throw and the catch block would catch it, right? So the catch block would always have only one parameter because there's only one ball thrown and the catch block only has to take that one ball. Okay, so this part of it is very similar to the argument and parameters of a function. So here, this is basically the argument, this is the parameter. You're passing this argument to this parameter and you pass it by value. If you forgot about like pass by value, pass by reference, pass by pointer, you have to review that concept. But here basically E would become a copy of donuts. This is going to be the local variable copy. I shouldn't say local. Sorry. It's going to be a separate variable which is going to have the same value as donuts, and the scope of E is going to be only within this catch block. Okay. So in this case, so let's say like the user enters 2 for donuts but enters 0 for milk, or let me just like follow this, enters 12 for donuts and 0 for milk. Everything goes here. As soon as we get to this if block, we throw number 12. We throw the value of the variable donuts, which is 12. So the control comes here, E becomes equal to 12, and we just like print C out 12 donuts and no milk, go buy some milk. Okay, and the catch block finishes and the program continues. Okay, if the user provides the right data 12 and 6, then this if block is going to be skipped. The try block continues. It would do the division and then it would skip over the catch block and the program continues. Okay, now you might ask, why do we have to throw something? There are two main reasons for that. The first important reason is that in one program there might be several exceptions happening. There might be several things that might go wrong. Okay, so it would be possible to have multiple catch blocks, right? So we have to identify which block should catch our exception. So how do we identify that? By providing different data types, right? So like one time we might throw an integer like here, and for another exception we might throw a double or float or character or non-primitive data types, a string or user-defined data types, classes, objects of classes. So that's the first reason. The other reason is that we might want to use some information and provide some information to the user. So here you can see that we provide that information to the user that, oh, we have this many donuts, but we don't have any milk. Okay, or we might have, for example, codes for our errors, right? And we can like provide those codes to the user, and like we want to throw that code and the user can look into the manual and figure out which error happened. Okay, so this is the second reason that we throw something. It's not just like getting out of this try block, we are basically be throwing an exception. This is the main topic. Sorry, the the is the essence of exception and exception handling. This part of the code is called exception handling. So we have try, catch, throw. Now we're going to see more about this. I already explained this. In normal situations, the catch block is skipped. In exceptional cases, like the throw happens and you're going to go to the catch block and the control goes over to the catch block. So the part of the code that does the operation is within the try block. But before we might have a problem with the user defined value, we might have to throw an exception, right? And there's going to be more code after that part in the try block. So here is like basically explaining like what I just covered, and like to throw an exception, like we just throw a variable or an object. It can be a value of any data type. It doesn't have to be primitive data types. Primitive data types are basically the data types that the C++ or the programming language comes with, like integer, character, float, double, boolean. Or it can be non-primitive data types like string, which is a class, or let's say class of students. We might want to throw an object of that class, or throw an object of any other class that the user defined. Oh, sorry, the programmer defined. I shouldn't say user defined object. Sorry, I should correct myself. Non-primitive data types. um, and throw causes the flow of control to go to another place, which is the catch block. The catch block, as mentioned, like it has two main applications. So the type of the catch block parameter identifies which catch block should catch the exception. Also, like it provides a name for the value, so like we can use that value in the catch block to provide a message to the user or do some sort of operation in the catch block. Try blocks are similar to if-else statements. They come together. If everything goes well, the catch block is not going to be compiled or not going to be executed. A big difference between try block and if-else, try catch blocks and if-else statement is try block's ability to send a message to one of its branches. So we're going to talk about that a little bit later. So one thing I should mention that like in almost all of the compilers, the exception handling is enabled. But in some funky C++ compilers, you might have to tweak your settings to enable the exception handling. So just wanted to mention this. And this basically provides like some sort of flowchart for how the exception handling happens. If nothing throws an exception, basically statement following the try block is going to be executed. So if we finish the try block and then we go after the catch block, if a statement throws an exception, we go to the exception handler, like which is the catch block, and then again like it follows what comes after the catch block. Now, can all try catch blocks be replaced with if else blocks? So in the example that I showed you a few slides ago, I showed two programs. One of them was using if else, the other one was using try and catch. Can all try catch blocks be replaced with if else blocks? In the case that like we were doing everything in the main function or doing it in all in one function, it is possible to just replace it with if else. But the main application of exception handling is where you call a function from another function. So here we have very similar program. So we want to do division. So we have two variables, x and y. Here, like I provided the values here, but like let's say like we were getting it from the user, and we don't want to do the division ourselves, but we want to call a function that does the division for us. Okay, so this function is very simple. It's just like you can just like say return m divided by n, right? But what if n is equal to 0? What if the value of y that the user entered, or like in this case the value that we specified here, what if it's equal to 0? Okay, pay attention to the case, to this part, the return type of this function. So like this function is supposed to return an integer. Okay, so here what do you want to do with if else? You can't do it like with if else, because you can say like if n equal to 0, what do you want to return? You can't just say return, because you're supposed to return an integer. And if you return any other integer, how is the user supposed to know that what got returned is an error code or is the result? Okay, so in this case, we can't replace the try catch with an if else. So you see here, we do the division in the try block, and once we go to the function, once the control goes to the function, we write an if statement. If n is equal 0, throw number, let's say 100. Okay, so once you throw something, it means that the control has to go to the catch block, right? Has to go to the exception handler. So basically, in this case, you get out of this function and you go to the calling function, which was the main, where the division was called, and the compiler looks for the catch block that would catch this exception. We have a catch block that catches this exception because it takes an integer. So at this point, if n is equal to 0, it would just come directly here and it would print division by 0. Okay, so the main application of exception handling is where a calling function such as main calls another function. You should know that in Java, exceptions are thrown automatically, but in C++, it's the programmer's duty to do that. And I emphasized here that like once you have a return type, so like once your program is supposed to return a value, it should return a value in all cases, right? So we can't just say return, right? This is like a novice programmer's fault. Sometimes they just write return and we get an error. Why? Because we get a syntax error in this case, because you're supposed to return, excuse me, an integer. So throw would kick you out of the function, would kick you out of the try block, and the control, the flow of the program goes to the catch block. You can think of exception handling as a way as a way of these two functions communicating between each other. So here, basically, this function is talking to the main function, saying that, oh, I have an exception, so I have to get out. You handle it for me. Okay, so in this case, you can think of this exception handling as a way of these two functions communicating with each other. So I mentioned earlier that what you throw can be a variable or it can be an object. So because a throw statement can throw a value of any type, it's common to define a class whose objects can carry the kind of information you want to throw. So you basically, you design, the programmer designs a class only for the sake of exception handling. This is an exception class, and it can have different types to identify different kinds of exceptional situations. So let's look at an example of that. Let's look at this part. So you can see this part, we just have a class called no milk. So this is like going to be a data type, right? A non-primitive data type. And here you have a constructor, default constructor, non-default constructor, a getter or an accessor, and you also have a private member variable. So instead of throwing integer, so here we are throwing an object of class no milk. This is a non-default constructor, right? This is a non-default constructor, and we are calling it explicitly. So it means that an anonymous, a no-name object, excuse me, a no-name object is going to be instantiated, right? And the catch block catches the no milk object here, and using the getter, it would print the value of the donut numbers. So this is a good example of an exception class. As mentioned earlier, one try block can have different catch blocks, okay? Because you might have different errors happening. So let's say like here in the try block, we have a function call. We go here. This example is only for educational purposes, right? I didn't have to write two functions. I could do this like in one function, but this is only for educational purposes. So in the try block, we call this function. So the control goes over here, and the uses might go wrong. It would call another function, so it would come here, and here this is just like an example to showing you that, okay, let's say like we would have like, you might have three different errors. If error 1 is equal to true, we're gonna throw an integer. If error 2 is equal to true, we're gonna throw a constant array of characters. So this like by default in C++, anything that goes between double quotation, it's going to be considered a constant array of characters. And if error 3 is equal to true, we're going to throw a string, a non-primitive string. This is basically, if you remember, this is like a non-default constructor for the class of a string. It would create a string object for us, and it would throw this object, an anonymous string object. So this is a primitive string, which is like an array of characters. This is a non-primitive string. Somebody was asking me the difference between these two in the class, so I want to differentiate between them. So three different errors might happen in this function, right? Once the error happens, once we throw something, the control first of all goes to where this function was called. So it would try to find an exception handler here. But here we don't have an exception handler, so it would go back to again where this function was called, which is right here. Now we have exception handling. We call this a call stack. So once the throw kicks you out of the function, um, the controller would follow the function calls to find the catch block. So like it would go like to where this function was called, then like where this function was called, until it finds the catch block. If we forget to put the catch blocks, the program terminates. This is going to be an error. But here, like we provided the catch blocks. If 8 is thrown, this catch block would catch the exception. If error 2 is equal to true, this catch block would catch it. This is so let me explain this one again. Somebody else was asking this question. This is a pointer to a constant character. So basically this is a pointer pointing to an array of characters which is constant. Okay, so this, if error 2 happens, this one would be called, this one would catch the exception. And finally, if the error 3 is equal to true, then the third catch block would catch the exception. So this shows that a try block can have multiple catches. One other thing that I wanted to emphasize here is that if you remember about the functions and how we pass something to the function, there were three main methods: pass by value, pass by reference, pass by pointer. So you can see that for passing or for throwing these exceptions to the catch block, we can have also the same thing. We can have pass by value, we can have a pointer, we can have a reference. So in this case, E is going to be basically like a separate variable. Like here, like we might have this is like just a nickname for the object that was, or sorry, an alias or a nickname for the object that was thrown. So I just wanted to emphasize that, like, if you forgot like what pass by value and pass by reference are, like you should review that. One other thing I wanted to emphasize, so like I bolded this one here: no automatic type conversion is done with exception. So in C++, if you write something like integer m is equal to 2.2, that's going to be okay, because automatically type conversion happens. Or if you call a function that is expected to get a double, but you pass an integer, that's going to be okay, because automatically casting happens, automatically type conversion happens. But in exception, this doesn't happen. So if this was 8.2, we would have an error, because we don't have any catch block that catches a value double, a double value. Okay, so if this was 8.2, we would have a error here. You can throw non-primitive data types. So like this is the example that, like, this is the explanation for the example that we just saw. And I also mentioned that you can also you can have like multiple catch blocks. So here we actually have two different classes: one class negative number, one class divide by 0. Okay, look at this class. What is this about? Like, it's an empty class. So this is like basically a dummy class, or it's called a trivial exception class, which is only going to be used to create a data type for exception purposes. So you can see here that we have like two different cases. In this case, if something is less than 0, we throw a negative number. If we have division by 0, we're going to throw the data type division by 0. So again, this is a default constructor that would instantiate an object of class divide by 0, and then it gets thrown. Same thing here. This is the non-default constructor for the negative number. So if these exceptions happen, the negative number, this first catch block would catches the negative number object. If this exception happens, the second catch block would catch the divide by 0 object. Okay, it's okay not to provide a parameter name here. So because like we're not doing anything with this parameter here, so like here, like you don't have to, you can just basically skip providing the name for the parameter. So like that's what I was saying. This is called a trivial exception class. There is nothing to do with the catch block parameter, so it can be omitted. So like if, so you see that here, like we didn't need to do anything with the parameter. Like let's say, like I could say divide by 0 g, but I'm not doing anything with that g, so like it can be omitted. Okay, so I explained this one. This is it's a dummy class, which is also called a trivial exception class. Okay, now, excuse me. C++ has a library called exception library. So similar to other libraries like IOStream or string or time that you have seen, we have another library called or IOmanip, like different libraries that you might have seen like in your previous courses. We have an exception library, a standard exception. In many compilers, this is already included in the IO stream, so this line might not be necessary. Okay, but it's a good practice to put it anyways, because you never know which compiler you would be using. In some compilers, this is not included in the IO stream, so that's why like I put it here, include exception. Okay, and basically what this is, like it provides a class for exception. So like it's a class exception defined in this library that has many subclasses, which we're going to see later. And it's a good habit to inherit your, as it's shown here, you can inherit your own exception class from the standard exception class. So as I did here, class my exception is inherited from the standard exception class. Again, if you forgot about inheritance, it's a good point to go back and review the concept of inheritance. Okay, and here we have a function that throws an exception. This part of the code, I'm going to explain it later in the future slides. Okay, so the class of standard exception has many subclasses, and each class would be corresponding to a certain exception that library can handle, that class can handle. So for example, one of them is bad alloc, or like bad allocation. So let's say like you want to allocate a huge array, like a huge dynamic array. Of course, like your memory might not have enough room for it, right? So this, if this happens, basically you are catching this with the exception as an exception object. So like which object is thrown here? If this happens, an object of class bad alloc would be thrown. But class of bad alloc is a child of class exception. So if we use polymorphism, we can catch this exception in this block. So this is what's happening here, and we can handle it over here. I haven't shown this here, but basically this is a method or a member function of class exception that would just print what the error is. Okay, so again, I just want to emphasize that there is a standard exception class that has several child subclasses. Each one of them is in charge of handling one sort of exception. This one is, for example, is in charge of bad allocation, right? If you run out of memory. So like if this, and it's going to be thrown automatically as soon as long as you include this this header. So once the exception is thrown, the exception that's going to be thrown is going to be of kind bad alloc, right? Which is a subclass of class exception. So it means the parent class exception can also, like, you look at this ampersand here, so like we are using polymorphism to catch this exception here. So, and then it would print something for the user's information. This is another example using, let me see what this is. Okay, so this example, like we wrote our own class, but we inherited that one from the standard exception class. We inherited in the public mode, and you can see that we have overridden the what function, member function that exists in this class, right? So like whenever, like this is a virtual function, so like again, like please review the concept of inheritance and polymorphism. So in case this exception happens, we have overwritten the the what member function of the standard exception class. Let's look at here. So it says try, and in the try we only have like a throw. So throw my x. What is my x? Like we have instantiated my x as an object of class my exception. So like it would go here, and we we catch, like the catch block catches the exception, and using the parent class, and when it says like e dot what, it basically should print the message that we want, because this is of kind. So like because we're using polymorphism, it should write this message. So we have placed a handler that catches exception objects by reference. So you can see like in C++, polymorphism can happen with pointers and reference, right? So like then therefore this catches also classes derived from exception, like in our case, my exception. If you want to see a list of subclasses of the standard exception class, I should have done this lowercase, because E exception, standard exception, E is lowercase. I highly recommend that you see this first link here. I hope that this link always exists. So all exception thrown by components of the C++ standard library throw exceptions derived from this exception class. So like that's what I just explained. We have a parent class, and then there are subclasses or child classes. Okay, this is another concept that you should know. Let's say like here we have two classes. We have one class that is derived from class exception. We call it my exception one. and we have another class myException2 that's derived from myException1, and we are throwing something here. We are throwing the myException1, okay? So or like we might be throwing myException2. So one thing that you have to be very careful is that the child class should come first in the catch block. The catch block that would handle the child class exception should come first. The parent class should come next. Why? Because if you put the parent catch block first, even if you throw exception of this kind, the parent class can catch it. The parent catch block can catch it. So in cases where you have inherited classes, you should make sure that the child class catch block is before the parent class catch block. Otherwise, the parent class catch block will catch the child class exception. Okay, review inheritance and polymorphism for this case. So like you can see here, like myException1, I didn't have to derive this one from exception. So like, and like in this case, like there wouldn't be any problem because um, a child cannot act as a parent, but the parent can act as a child. So you might have like you should make sure that the child, sorry, I might have like said it the wrong way, but the point is like the child catch block should come before the parent catch block. This I'm gonna explain it a little bit later, actually just like right here. So we have one sort of catch block that you can see doesn't have any data type. Instead of data type and the parameter, we put 3 dots. This is called ellipsis. So we call this one a catch-all block or a default catch block. A default catch block doesn't care what data type is thrown. Any data type that is thrown, this block can catch it. Okay. So one thing I should mention is that the order is important. You already saw that, right? So let me also, like before mention this, let me go to one example that I showed earlier. This example. So in this example, the order of the catch block is not very important because there are different data types. Okay. But what if this one was also int? Then this one would never be executed because as soon as you throw an integer, it would always go to here, right? You only throw something, you only throw one thing, and only one catch block would be able to catch it. The one who catches it first, that's going to be it, right? Once the catch block finishes, all the other catch blocks are going to be skipped. Okay, so like that's what I wanted to mention. I forgot to mention that over there. But now when it comes here, so now this catch all block, which we identify it by putting 3 dots in the parentheses, in the round brackets. This catch block, like, can you guys tell me, or like, can you guys think, where should this catch block be located? Can it be the first catch block, or should it be the last catch block, or should it be in the middle? It should be in the last catch block, because if it's the first catch block, the other catch blocks are going to be skipped all the time. So note that the catch all should be the last catch block, otherwise the other catch blocks are always skipped. Okay, and because the exception could have any type, you can't refer to the exception object here. So there's no parameter, there's no variable or object here anymore. Okay, so like this is like what's happening here, right? So like if we throw like any of these two exceptions, like this block or this block would catch it. If we throw any other exception, this would be catching it. It doesn't care if it's integer, double, character, um, let's say like a non-primitive data type. It's like one of those ball huggers in a volleyball game or a basketball game that like no matter like where they're supposed to be, they just want to catch the ball. So this is gonna be um, the catch all block. Um, so exceptions in functions, we already covered this one, but I want to mention a topic that's sometimes it's optional to do, but it's a good habit to have it. So in some cases, an exception generated in a function is not handled in the function. So all of the examples that we have seen so far are like that. So for example, let me go back to the example here. So we are throwing an exception here. An exception is generated here, but is it handled inside this function? No, it's handled outside the function. So that's what it meant here. That's what it meant by, in some cases, an exception handled in a function is not handled in the function. It might be some program student. So like it's going to be handled like in another function, in like where the function was called, in the calling function. In this case, the program places the function in, so like it's a good habit that in the signature of the function the programmer provides some hint or some indication that warns the other programmers that okay, this function that I wrote here, um, it has an exception that is going to be handled outside the function. So an exception, a specification, or also called a throw list, appears in the function declaration or in the function signature. So and also like the definition. So here you can see that we have, for example, double safe divide integer int d, and we say that oh, this function is throwing this kind of data type that's not going to be handled inside the function. Okay, or also like it might throw like multiple exceptions, so like you have to include all of the exceptions that are going to be thrown. This is optional, we don't have to do it. But having said that, if you do it, you have to do it right, otherwise the program might run unsuccessfully. So why do we want to do that? Because we want to make our program as readable as possible for the other programmers that might be working with us. Okay, so we might so like you can see here, this is the prototype of the function, right? So when we wrote the prototype of the function, we identified that this function might throw an exception of the type divide by 0. Okay, and in the definition of the function we did the same thing as well. Okay, and you can see that like we only have to do it if the exception is not handled inside the function, is handled outside the function. You see that like the exception that's thrown here is handled here, which is not in the safe divide function, but it's in the main function. So like I explained this already, so like I'm just gonna skip this. This is like, again, like this is the topic that I explained before. This is about the call stack. If a function throws an exception, right, that's not handled in the function, it's gonna be going back to where it was called, to the function that was called. So you're gonna have a call stack, and it's gonna try to look for the handler in that function, right? If you have like multiple function call, like the example that we have, uses might go wrong, this might be like multiple steps, right? So this might be stacking up, right? So that's why it's called a call stack. And this slide is trying to explain it. I'm just gonna skip through it, but you can read the slides. I provide the slides. If you wrote a function and you not list the exception, that's okay. That's okay. So let me go like these examples that we did previously. The functions that we wrote, let me find an example. Like this example. Like we already did that here. Sorry. Let me find this example. We didn't write any throw here, right? We didn't write the throw list here. It's okay if you don't write anything, right? It's an optional thing I mentioned. But if you write the throw, you have to specify all the exceptions that you're going to be throwing. If you don't list that is one specific exception, and that specific exception happens, the program terminates. Okay, so here for this one, I have provided a throw list, but it's an empty throw list. So it means that we mentioned that this function doesn't throw anything that's going to be handled outside the function. If it does, the program ends, right? So this function, the second one, it says that it only throws this two different data types, different exceptions that are going to be handled outside the function. If, for example, inside this function you throw an int and it's not caught there's no catch block inside the function to catch it, then the program terminates because you didn't identify int. But if you write the program the way that we normally did before, like I introduced this topic of throw list, every exception is going to be handled okay. If not caught by the catch block inside the function, it's going to go outside, look for the catch block. If there is no catch block outside in the call stack, then it would terminate. Okay. There is a keyword called no except. So the no except keyword declares a function that never throws. So again, this is like very optional. It's not used that much. This is only for your information. Rethrowing, I should emphasize this one. Can you guys see one thing that is weird here in the line that's highlighted in red? What are we throwing? So if you have like a throw statement without actually an exception to throw, this means that the last exception that got thrown, this can only happen, a throw without any parameter, without any exception, can only happen, without any argument or without any exception, can only happen inside the catch block. If you have this, it means that the last exception that happened, throw it again, rethrow it. So like it's as if like somebody passes you a ball and you pass it back, like you pass it again, right? You throw it again. It's called a rethrow because it resumes throwing whatever the handler just caught. Whatever the catch block, which is the handler caught, it's going to throw it again. Sometimes in nested throws, nested try catch blocks, this is going to be uh, um, useful. Speaking of nested try-catch blocks, similar to nested loops or nested if-else, you can have nested try and catch. So you can see here like we have a try-catch block inside this try block. The same thing here. So and so like here, like for example, you can see that here like we are throwing this again. Okay, so we are well, like whatever got thrown here, we are throwing it. Now this time it's gonna go here to this catch block. So like inside the nested try catch blocks, something like this might happen. Oh, I think like we are getting to the end of the lecture. So when do we want to throw an exception? So in the first slide, I mentioned that we want to throw an exception um, in the exceptional cases, as the names mentions it, like as the names like shows it. So only in the exceptional cases, only like for the runtime errors when we don't know like what the user is going to enter, and like we predict that if the user enters a wrong input, something might go wrong. So throwing exception is generally reserved for those cases when handling the exceptional cases depends on how and where one function was invoked. As I mentioned, like if we don't have functions, we can just write if-else blocks. And some programmers prefer that because it saves time. Okay. In these cases, it's usually the best option to let the programmer calling the function that handles the programmer calling the function handles the exception. And an uncaught exception ends the program. So like to read more about this, please go to this website. It's a good website. It has like many interesting topics about C++ or other programming languages. So also mentioned that some programmers prefer not to use exception as much as possible. There's an S missing here. Um, um, if you can easily write your code to handle the problem, don't throw an exception for saving execution time. So one exercise that I want you to do, please go to this website and find all the subclasses of the exception standard class and write a complete C++ program that handles at least 3 of the exceptions defined in the standard exception class. For example, bad allocation was one of them. You can have overflow, underflow, or like go to that website to find the list of them. And then write a class. So basically use a non-primitive data type for throwing the exception and inherit your class from the standard exception superclass. So I want you to do this to just have a review of inheritance, polymorphism, classes, exception, and many other concepts like allocation, dynamic allocation, and like many other concepts. So this would cover many concepts that was covered in this video. One thing that one of the students asked in the class, and I want to explain it, one student was asking, why do some programmers prefer not to include this use this line using namespace std, and like whenever they wanted cout or cin, or like whenever they want to use the namespace standard, they write std : cout or std : cin. One main reason for that is that like in a big program you might be using multiple namespaces. Namespace is a collection of variables, objects, classes, functions. And when you have multiple namespaces, there is a good chance that some of these namespaces have common variable names or common object class names or function names, right? So if you include all of them, if you write the directive for like all of them, then there's going to be confusion for the compiler, right? So like which one we want to do, like then like the wrong namespace might be used, right? So like that's why like some programmers, they just write std colon colon instead of like writing this line. They accept the trouble of writing the std colon colon every time to prevent that kind of potential error happening. That's all for about exception handling in C++. Thank you so much. All the best.